Okay, so same kind of thing, right? They should have told us these lines are parallel, but I guess the picture is good enough. They look parallel. So parallel lines. So whenever you see these parallel lines cut by a transversal, you think, oh, we're going to do the Z angle thing or something like that. Right, right. You're right. That's generally the idea. This one's a little different though. They're saying angle 5 is 5 times x plus 1. So I'm going to put that in right there. This one is 5 times x plus 1. And then they're telling me angle 4 here is minus 4x minus 22. So that would be this one right there. Minus 4x minus 22. Okay, so they give me angle 4 and angle 5. And then somehow from that, they want me to find x. Well, here's I'm going to add some rules to what we've learned. So basically, we already know that z angles are equal, which are called alternate interior angles, are equal when you've got parallel lines. We already know that. But now we need a new fact. Fact number 2, something called corresponding angles are equal when you've got parallel lines also. Corresponding. Now, what are corresponding? Corresponding mean same position from one intersection to the other. So in other words, how do I put that more clearly? So both in the both say upper right or lower left, etc. So same position of the intersection, same position from one intersection to the other. That's called corresponding. They correspond. They fit in the same place. Those are always equal. So how can that help me? For example, angle 4, look at angle 4 here. We're going from this intersection down to that intersection, right? Those are our two intersections. And angle 4 is the lower right corner of his intersection. Which angle down here at the other intersection is also in the same place, the lower right corner?
8.
Yeah, exactly. So that's got to be the same. So you just bring that down. You go, oh, angle 8's got to be the same. So it's got to be minus 4x minus 22 also. Those have to be equal because they're corresponding. They're both in the same position of the intersection, lower right, lower right. Or I could have brought this one up here and said, well, look, can't you just do upper left, upper left? Totally. You can do it that way too. That's got to be the same because they're both upper left, upper left. So they've got to be the same. You can go either way. Okay, and then once you've done either one, you don't have to do both of those. Either one of those, then we're ready to solve it. Why? Because these guys got to be equal because they're diagonal. Remember that? Let me add that fact again. I think you already know it though. And that is, whoops, sorry, I'm bumping the thing there. Okay, so we know step 3, diagonal angles are equal. They're called vertical. So because of that fact, I just go, oh, okay, well then this, which is the 5 parenthesis x plus 1, has to equal minus 4x minus 22 because they're diagonally apart from each other. So they have to be equal now. So now we can just solve for x. See how that worked out? So we use the fact that we have two parallel lines. So when you have that, you know z angles are equal, you know corresponding angles are equal. So I went with the corresponding thing. So I just said, okay, this angle, bring it down here, or this angle, bring it up there, either one. And then the diagonal angles have to be equal because those are always equal. They're called vertical. Set those equal, solve for x. So let's do it. So now we just distribute 5x plus 5. The other side is minus 4x minus 22. Now we have x. X is on opposite sides. We've dealt with that a couple of times. You know what you do. You do the opposite. So I'm going to add 4x to both sides like that. Like that. Bring down that minus 22. Keep going. We're almost there. So now let's subtract 5 from both sides. And we get 9x is minus 27. Last step is divide by the 9. And so my x is negative 3. That's all they want on this one is the answer for x. Just put that in the box. And there we go. That's how we solve that problem.